On this worksheet says a movie stunt driver on a motorcycle speeds horizontally at off a cliff, 50 meter high cliff. How fast must be he leave the cliff in order to land on the level ground below, 90 meters from the base? Yeah, so your diagrams become really, really important here. And I don't mean like they have to be gorgeous, because I don't even know how to draw a bike. That looks like not like a bike. Oh, his knee's pointing in the wrong direction. Okay, the point is he's heading off of that at some unknown speed, right? Yeah, we can call that Vx. Now, the most important thing about this, and then there's a vertical, is 50 meters. And basically, he's going to project and land over here 90 meters from the base. Right? Now, the way to do these problems, and you're going to have to do this every single time, is to break up into components. You have to break it up into the vertical component and the horizontal. Am I still on the board? Yes. Okay, so now in the vertical, we've got to deal with acceleration. This object is accelerating, right? It's accelerating down. What's its rate of acceleration? 9.8. Let's not call it negative yet.
Because we have 50 positive?
Yeah, we have to decide our sign convention. So some of you automatically want to put this as negative. I would consider not. I would consider making down positive in this question. Does anything actually go up? No. Nothing goes up. So why would you want to put yourself through all that? Now, in the vertical, it's accelerating. So let's call it delta y, just because it's in the vertical direction. Delta t. V, I'm going to call this V naught in the y direction, V in the y direction, and A. So now you see all the variables I'm dealing with in the vertical direction. In the vertical direction, its speed is changing, right? As time goes by, it's going to get faster and faster because it's accelerating in the vertical direction. Does that make sense to you? So what do we know? Okay, and then, but horizontal, so here, A equals 9.8, right? Yeah. Okay, horizontally, what can you say about the velocity, the acceleration horizontally? A is 0. Yeah, so all we need is delta x, delta t, and v. And v is vx. And what the vx, yeah, v naught x, which is going to equal to vx, right? What's going to happen to that v speed as it goes through? It's not going to change. It's going to be the x component stays the same the whole time. I'm going to slap something on top of this for a second. Looking at this worksheet again, if you just look at the horizontal components of projectile motion, you can see this vector. What do you notice about the size of the vector? It doesn't ever change, right? Because horizontally, there is no acceleration. So that velocity stays the same throughout the whole path. But what if I look at the vertical vectors? What's going on there? As it goes up, it's slowing down, it stops, and then it changes direction. This is kind of like what we've done in class. So those two motions, the vertical and the horizontal, sort of operate independent of each other, right? So that's why in the x direction, we don't need v naught, v, and a, because those three things don't matter, but we do need them in the vertical. So now, can you fill in from the question everything we know?
So delta y being 90? 50.
The y is the vertical, so yeah, 50. And we're calling that positive, right? Because we called a positive. What else? Yeah, 9.8.
I think delta t, do we not know? We don't care.
Well, let's not. We don't know it, but let's leave it for a second. V naught y is 0. Are you guys comfortable with that?
Yes.
Yeah.
Why is it 0?
No, it's not. Well, the motorcycle is moving.
But it's moving horizontally.
It's moving.
Oh,
Right.
This is complicated.
Yeah. So then,
Oh, it's easy to mess up. It's
what
really
else do we know?
Really, this
It's
is
V.
you don't know.
Vy is 50 if t is type back.
We don't need.
Vy is the speed it's going down here. We don't know that. But we do know one other thing.
Oh, delta x.
Yup.
90.
Because it's vertical. I want to distinguish the y from the x. Because now we have a two-dimensional problem. Okay, this is everything I know. What I want to say to you here is this. We've got two sort of sets of data, but really it's all part of one problem, right? There's one motorcyclist, and he's doing something. So what can you say? What do you think that implies about the time?
They're gonna be the same.
They have to be the same. Same. So I don't know time, but I know they're connected. What's my unknown? What's the thing I'm asked to find?
VY.
How fast?
So you've got two V's here. Which one do we want?
VX. No, it's VY.
We have to find
It's VY.
no V. No, neither. We have to use both of them.
No, because it's saying with what is it? What's the question say?
How
How fast?
Horizontal.
Yeah, how fast must he leave? So they're actually asking for this. This is my unknown.
Oh.
And this is what's going, so remember, the Vx doesn't change. When it hits the ground, Vx is going to be the same as it was.
Yeah.
What I don't know and don't care about is this.
You need to figure out the time. for
So
the
you see here, I have 1, 2, 3 pieces of information. I can use that to find time here, but that's not what's going to help me. What's going to help me is putting that here
To find.
to find this. So it's
First we find the T.
Yes.
Then we can use that.
yes. First you have to find the t. So with Vy as my don't know, don't care, I can set it up like this. Delta y equals Vo delta t, Voy delta t plus 1/2 a t squared. And this is going to be, oh yes, let's put it in. So 50 equals, someone has a calculator, should help us out here. So it's 4.9 t squared, t equals,
3.2.
is it?
I haven't sorted it out. Oh, I literally just took it all in terms of radicals and plugged it all in.
Yeah, you can do that. And you probably should carry more digits here. All right, then we're going to take that number and put it in here, 3.2 seconds. And now this equation
So it's
becomes,
equals delta V.
let me just write it out, Vx equals delta x over delta t, which equals 90 over 3.2. And what does that equal? I hope so.
Yeah, that's.
Is that right?
I mean, that's the answer that you have.
I know, but someone check it.
And then do you want us to write out a
Yeah.
sentence?
This makes
It's kind of the exact same, just adding it.
Okay, so now, let me just stop this.